we're also out of coffee.
Level with you all. Level with you all. Level with you all. Level with you all.
Would you like some coffee?
In my opinion, there are three things that made all of this possible.
Level with you all.
Back.
I would love to spend a year in space. That, I can honestly say, I don't miss anything from planet Earth, not being a creature on planet Earth anymore.
Do not believe you that you can get.
Will not work in a weightless environment. I guess you could stick your tongue down there, kind of like a butterfly drinking nectar out of a flower or something, but our tongue isn't long enough.
I kind of start talking about really hot liquid sloshing around your face.
The NASA engine,
From a bag. It's a travesty, really.
Level with you all.
I can't even.
perhaps 70% of the effect of a cup of coffee. I've got it right here. And this is a zero gravity cup.
Level with you all.
Is an example of something that you do not realize how important that ritual is or how common it is in your daily routine until you can no longer do it.
Don has a patent on this cup, proving the Space Cup design on other missions.
This is generation 2. Shape of this.
Okay.
There's no art in this at all. One,
Generation 1.
that's generation 2.
Generation 2.
This is generation 3. The skills that my mother taught me to slip cast porcelain, these zero-G cups.
Finally, it's good enough for the Museum of Modern Art. Don's cups is now in their collection. It was donated by Italian astronaut Samantha Cristoforetti.
If you understand your science correctly and then you do your engineering to make something useful from your science, it should have an artistic measure to it. You go into the frontier and you make an observation and it's like, whoa, I have no idea why that happened.
And that's where science gets done, like Miniverse. Miniverse is brought to you by another astronaut, Chris Hadfield. He was the guy doing that cool washcloth of water experiment on the space station that you just saw. Chris takes you on a road trip across our solar system, only scaled down to the continental United States, so no spaceship required. That yesterday's coffee is tomorrow's coffee, because they recycle their pee to make their drinking water. So,
Coffee.
I'm doing, and that is brewing coffee in space.
Level with you all.
And so I have a pot of coffee here, bottom of the cup. How awesome is that? That is fresh brewed coffee. And that works amazingly well. All right, so you can see just because of the geometry of this cup, surface tension is carrying this fluid, this coffee, up right up to the lip. That is awesome.
I always have coffee when I watch Radar. You know that.
Of course I do, sir.
Everybody knows that.
Of course we do, sir!
Now that I have my coffee, I'm ready to watch Radar. Where is it?
Right here, sir.
Hello and welcome to Open Science. I'm Dr. Marshall Porterfield from NASA headquarters in Washington, D.C. Research.
People don't understand that a lot of the forces that we see on the ground are the same in space. Those actually don't change. But what does change is the impact of gravity. So with less gravity, then we start seeing small forces that we're not accustomed to dominating the fluid process. So we see giant spheres of liquid, we see giant bubbles, we see liquid going to places where they're not used to seeing. They see this absence of an up or down kind of thing, floating or sinking. Those things all go away, and so that catches us by surprise. And so there's really a lot to learn to make systems work in space.
So how has what you have learned in your research program contributed to the development of a more reliable spacecraft?
Bubbles plugging lines or liquid spilling and going someplace they shouldn't be, that kind of a thing. So as soon as we learn how to position and make fluids do things on their own using surface tension and not, say, gravity, then we learn how to expect where the liquid should be so that we can make refrigeration systems work, make filter systems work, make cooling systems work, make drinking systems actually work, that kind of thing.
coffee cup, coffee cup.
And you can learn a lot of that stuff on the ground too, but in space you see it on a big scale. With that, we can make a cup large enough to still exploit capillary forces so that when the astronaut brings it to his face, there's a gradient in the driving force from surface tension to drive that liquid right into the mouth of the astronaut. So but when the astronaut makes that connection, that serves as the bottom and it will drain the cup into his mouth at the rate that he or she takes it in.
Yeah, the video of seeing the astronauts use the coffee cups and the drinking process is very interesting. I'm sure that the audience is really going to enjoy getting a chance to see those videos also. But in addition to the coffee cup, your research has contributed to development or the modification of other hardware systems that are very important on the International Space Station. Can you give us some examples of that?
Right. So in the coffee cup actually has a lot of science in it and engineering too. So if we can design a system, for instance, for processing urine or processing wastewater other streams or condensing streams of water by just having a simple, maybe it's a complex shape, so that you could actually have a significant savings if you use something like a cup. And this last demonstration is, hey, you can have scalding drinks in open containers safely, just like you do around your coffee with your coffee cup around your laptop in the morning.
That is awesome.
Thank you, Mark. Drinking coffee in a work environment is an important part of life on Earth. And because of your work, now it's possible off the Earth as well. To learn more, go
Morning Joe recently got an upgrade. On April 20th, SpaceX delivered to the space station a new microgravity coffee machine named IS Espresso. Our aerospace engineers have designed a coffee maker that can function in microgravity conditions, says David Avino of the Italian engineering firm Argotec.
Coffee cup.
Working together with the coffee company Lavazza and the Italian Space Agency, we have brought authentic Italian espresso onto the International Space Station. No one wants to drink Italian espresso from a plastic bag, however. What astronauts need is a zero-G coffee cup. Fortunately, 6 of these wonders have been delivered to the space station as well.
Coffee cup.
Fluid physicist Mark Weislogel of Portland State University and IRPI LLC, who helped invent the cups, explains why they are necessary. Coffee out, or you could throw it out of the cup and suck down the scalding blob that forms in the air. No thanks.
Coffee cup.
The zero-G coffee cup solves these problems by going with the flow, by the combined effects of your mouth, the wetting conditions of the fluid, surface tension, and the particular shape of the cup. This oddball cup wouldn't work on Earth, but it is a marvel in space.
Coffee cup.
Operation of many critical space station systems, air conditioning, refrigerators, toilets, cryogenic fuel tanks, medical treatments, the water supply, and everything else that involves liquids depends on the ebb and flow of fluids.
Coffee cup.
En route to Mars, he adds. Compared to those other systems, coffee is not in the critical path of operation, says Weislogel. Try telling that to the astronauts about 5:30 tomorrow morning. For updates from the International Space Station, go to www.
Advertisement. That's it. Forget about the Russians. We're doing an advert for Tiger Brand coffee. Tiger Brand coffee is a real treat. Even tigers prefer a cup of it to real meat.